The previous video looked at how we named benzene when it was bonded to only one functional group, side group, or branch. But what happens if there's two of them bonded to a benzene? First, we'd have to consider the concept of dominance. Each of these benzene rings with a functional group are not only considered monosubstituted benzene derivatives, they are also considered parent chains. A parent chain is a chain of carbons with a dominant functional group, or a longer carbon chain. And as a result, anything else bonded to these parent chains would be considered a side group. Of course, whether a chemical group is considered a dominant or a side group all depends on this priority list, as first introduced to you in the first video. Let's look at a couple of examples to see how dominance works with disubstituted benzene derivatives. In this example, we have a benzene, an alcohol group, and a carboxylic acid group. Out of these two chemical groups, the carboxylic acid group is the more dominant. Therefore, the parent chain would be benzene carboxylic acid or benzoic acid, thus making the alcohol group a side group. It is also important to note that since the carboxylic acid group is the dominant chemical group, the carbon the carboxylic acid group is bonded to in benzene is therefore designated carbon 1, and as a result, the other carbons on the benzene ring would be numbered 2, 3, 4, 5, and 6. This makes the alcohol group branch off of carbon 6 of benzene to give us the name 6-hydroxy-benzoic acid, or 6-hydroxy-benzene carboxylic acid. But as you learned in Chapter 11, in the nomenclature unit, the name with the lowest combination of numbers is most correct. Which leads us to ask, is the alcohol group really bonded to the 6th carbon of benzene, or the 2nd carbon of benzene? Since 2 is much lower than 6, the real name of this disubstituted benzene derivative is 2-hydroxybenzoic acid, or 2-hydroxybenzene carboxylic acid. With this disubstituted benzene derivative, there is an acyl chloride group and an amine group. Since the acyl chloride group is more dominant, then the parent name of this compound would be benzoyl chloride, and since the amine group is on carbon 3 relative to the carbon bonded to the dominant benzoyl group, then the name of this organic compound should be 3-amino-benzoyl chloride. With this disubstituted benzene derivative, there is an ester group and a nitrile group. Since the ester is the more dominant functional group, then the parent name of this compound should be benzoate. And since the nitrile group is bonded to benzene's 4th carbon relative to the carbon bonded to the dominant ester group, then the name of this organic compound should be 4-cyanobenzoate. But this name only addresses part of the molecule. We have not yet considered the methyl group of this organic compound. Any branching within the benzene molecule that is not part of the dominant or parent chain must appear alphabetically within brackets, giving us 1-methyl-4-cyanobenzoate. Of course, the 1 does not have to be there, as it is only formal to include it. It only marks the methyl ester group branching out of carbon 1 of the benzene molecule. And lastly, this disubstituted benzene derivative has a methyl group and a propanone chain. Neither of these are functional groups, and are in fact considered branches. Nevertheless, this branch in the box seen here contains a functional group, making it a parent chain, and whatever is bonded to it, a side group. In this case, the side is 1,3-methyl-phenyl. Since the carbon on the benzene ring that is bonded to the parent chain is designated carbon 1, then the carbon on the benzene ring that is bonded to the methyl group is designated carbon 3, giving us a disubstituted benzene derivative with the name 1-phenyl-3-methyl-propan-2-one. Now how do you name a benzene ring that is bonded to two chemical groups and neither are a dominant functional group?